Okay, if you give a traditional algebra student, I mean a modern algebra student now to this problem over here, they probably used a rational root theorem, and by doing the rational root theorem, they'd look at this and say, oh, there's no rational roots to the problem, and they'd give up, right? Another thing they could do, which I'm not opposed to, is to make a substitution, and the substitution would be u equals x squared. And if they did that, they would get x squared minus 5u plus 1 equals 0. Then use, I'm sorry, I didn't mean to say x squared. Sorry about that. Let me do that again. U squared minus 5u plus 1 equals 0. And that's fine, by the way. Right? You could do that. You could solve for u, then use the quadratic form to do that. And then, u is equal to x squared, and you're taking the roots of both sides. But I want to point out there's a different approach to the problem that's really not often discussed with students. And that's really completing the square. All right, completing the square in the problem. So let me take a look at it, and I'll tell you what I mean by that. That if I were looking at x4 minus 5x squared, and I were to complete the square in that, half of minus 5 is, minus 5 over 2. And if you square that, you'd get 25 quarters. And then I'd have to take 25 quarters, right? It couldn't make a different problem. Plus 1 equals 0. And you get a perfect square here. And what would that be? That would be x squared minus 5 over 2 quantity squared. And then I got to pull these two together. And what's that going to be? Minus 21 quarters. And then I want to write them as a difference of perfect squares, by the way. And a way to do that is write this as a square root of 21 over 2 quantity squared. And what do you get there? You get x squared minus 5 halves minus root 21 over 2. Difference of perfect squares, by the way. X squared minus 5 halves plus root 21 over 2 equals 0. Relatively easy to do, by the way. All right, that's a factorization of the problem. Right, and what does this equal? This equals 0. Then what are you doing over here? Let me make sure I got that written down for you. And by when I write them down, it's certainly written in a probably a neater fashion when I type it up than I do this over here. But this is rather easy to write down a solution of it now. What's it going to be? Well, x squared equals, I'm sorry. For the first one, it would be 5 over 2 minus root 21 over 2. The second one will be x squared equals 5 over 2 plus root 21 over 2. I just want to pull them together a little bit. X squared is equal to, this is 2, 5 minus root 21, and this is going to be x squared is equal to 2, and then you're going to get 5 plus root 21 there, all right? Now, someone's going to say, could you put the answer down now? Immediately. You could do it immediately. Now, what do you mean by immediately? You could write down x equals plus or minus the square root of 5 minus root 21, root 21 over 2. Square root of 2. And this is going to be x equals plus or minus, let's see, the square root of 5 plus root 21 over the square root of 2. All right? And there's nothing wrong with doing that, but I'm going to say that you might be surprised to look at an answer key and that answer would not be listed. I want to go through it, though, and simplify these a little bit, and I want to get their answer over here. All right? I want to get that answer over there. All right? The way I do that, I'm going to look at this one, the one I wrote down over here. And I'm going to at least, try to rationalize a little bit. So root 2 over root 2. And you get 2 on the bottom, by the way. Oh, by the way, I notice it's plus or minus. I'm sorry about that. What are you going to top? Root 10. And then minus, that would be 2 root 21. Now, a lot of students find this remarkable that you can actually denest a root. I want to go through that with you, though. I'm going to denest this now. By the way, I know it's plus or minus. I definitely have the 2 on the bottom, but I want to denest the root. And a way to do that is assume it can be done. And I'm going to assume it's going to be, the root of A, and then minus the root of B. I'm assuming that it can be done. I'm going to square both sides, and what do you get? You get 10 minus 2 root 21 equals, well, let's write this down. Now, if I squared the right side, I'd get a plus b minus 2 root ab. What do I know about this? I know that a plus b should be equal to 10, and I know a times b should be equal to 21 just by looking at this. Let me tell you why I know that. I'm looking at these things over here, 10, I see the minus 2 there, and I'm going to say that 21 is the AB. Now, I'm going to say that doesn't look difficult to me, but I'm going to say, the A and B. So I'm going to say the A and B have to be some combination of 3 and 7. They have to be. Why am I saying that? Looking at that, there's not much work on it. I'm going to say, looking at it, 3 plus 7 is 10, and 3 times 7 is 21. But you know what? You should really carefully look at this first before you say which one's 3 and which one's 7. All right, so, 10 minus 2 times root 21, this is definitely a positive number. So what do I know about this over here? This is equivalent to root 7 minus root 3. And that's why they're doing this over here. So they de-nest the roots in both cases, by the way. Relatively a nice trick to know, by the way. Assume it's doable and just go for it. Thank you.